Today we are going to discuss about the concept of radioactivity, that what the radioactivity is and how it works. First of all, we must know that radioactivity is purely a phenomena which deals with nucleus, or it is only and only a nuclear phenomena. It does not have to do anything with the environment of the nucleus, and it is independent from the pressure and temperature, both. Now, what the radioactivity actually is, to understand this concept, we must know about the stability of nucleus. As we all know that nucleus is a very stable structure and it is among the most stable structures in this universe. But then also, in a nature, there are few nucleuses which are not that stable, and in other words, we can say that they are unstable. Due to this nuclear instability, such nucleus shows the phenomena of radioactivity, and due to this radioactivity, the ultimately leads to the belt of stability. Now, what this belt of stability is, and everything is very much elegantly clear in your front. You can see that there is a curve which shows the ratio between the number of protons and number of neutrons. As I said, that majority of the nucleuses are stable, but few are those which are not. Now, first of all, we must clear that which nucleuses are stable and which would not be. So, in this curve, we see that there is a stability belt. Those nucleus which have the neutron to proton ratio between the belt of stability, like this, we will have a stable nucleus. It means that those ratios of proton to neutron which lies in this belt of stability, they all would be stable and they would not be prone to the phenomena of radioactivity. You can also see that there is a number of neutron 20 and number of neutron protons 20 in case of calcium nucleus. So in a periodic table from element 1, that is hydrogen, to calcium, proton to neutron ratio comes out always to be 1. That is, as much number of neutrons are present, that much number of protons would be there. But after calcium, that is from scandium, titanium, vanadium, chromium and so on, you will find that there is a sudden increase in the number of neutrons with respect to or in comparison to the protons. This is due to the fact that with increasing number of protons, there would be the increased repulsion between those protons, and as a result of which there would be more repulsion between those protons. Thermodynamics says that with increase in repulsion, there would be increase in energy, and with increase in energy, there would be increase in instability. So to overcome with this repulsion of increased number of protons, number of neutrons increases and they comes between two protons so as to minimize their repulsion. Thus, after atomic number 20, there is a sudden increase in number of proton in comparison to sudden increase in number of neutron in comparison to the protons. So all those nucleuses with the proton to neutron ratio which lies between this stability belt, they all would be considered as stable. Now we have 2 points. It is a point A and this is a point B. This point A, it is a radioactive nucleus. Why it is radioactive? Because it is not lying in a belt of stability. It is far away from the belt of stability. And the same is the case with this nucleus B. This nucleus is also radioactive, and it is also because it is far away from the belt of stability. Now we see that how these nucleus with the phenomena of radioactivity will ultimately comes to the belt of stability and they achieve stability. First, consider the case of nucleus A, which is radioactive and which is lying on the right hand side of the belt of stability. You can see here that here the number of protons is much more than number of neutrons, and that's why due to this increased number of protons, this nucleus is lying out of the belt of stability. Now if we want this nucleus to move in a belt of stability, what we have to do, or what this nucleus have to do, is it have to release alpha particles. Because as you all know that alpha particles are positively charged particles, they carry 2 positive charge. If there would be emission of alpha particles, there would be decrease in the number of protons, and slowly and gradually this nucleus with release of alpha particles moves in a belt of stability. Same, likewise, when we take the example of nucleus B, it is radioactive and it is lying on the left hand side of the belt of stability. It is again very unstable because it is not in a belt of stability. To achieve stability, it has to move in a belt of stability. Here, the number of proton is less, but number of neutron is high. If it tends or if wants to move in a belt of stability, it has to increase its positive charge. So that with increase in positive charge, there will be increase in protons and ultimately it will move in a belt of stability. Thus, in order to get this nucleus release beta particles. As you all know that beta particle is negatively charged, and with the release of negative charge, there would be the net increase in positive charge. So slowly and gradually, when this radioactive nucleus releases beta particles, ultimately it is increasing its positive charge and it moves in a belt of stability. So we can conclude that those nucleus with the proton to neutron ratio, when it lies from the belt of stability towards right hand side, they generally releases or emits alpha particles so as to move in a belt of stability. And likewise, those nucleus with proton to neutron ratio, where it lies in the left hand side of the stability belt, they releases beta particles so as to move in a belt of stability. This phenomena is known as radioactivity, and in this way we can know that which nucleus would emit alpha particles and which would emit beta particles. Because radioactivity is a phenomena which releases in which alpha particles and beta particles are released, but at the same time, in majority of nuclear reactions we see that with release in alpha and beta particles, at the same time there would be the release in gamma radiations or gamma energy. Now from where this gamma energy comes? So to know this, we must know that when nucleus releases an alpha particle, with this release in alpha particle, it gives a recoil energy. It is a Newton's third law. Every action has its equal and opposite reaction. When alpha particle releases, it gives recoil energy. When beta particle releases, it gives recoil energy to the nucleus, and as a result of which this nucleus moves to its excited state. All the excited states are unstable because of their high energy. They all tends to come back to their ground state. So these excited nucleus, due to the recoil energy which they get from alpha and beta particle release, they again tends to move to their ground state. In this phenomena, they releases gamma radiations. So now we can conclude that the radioactivity carries itself, or it moves in a way which have two stages, that is the primary stage and the secondary stage. In a primary stage, they releases alpha particles and beta particles, and in a secondary stage, because due to the release of alpha and beta particles, the energy of the nucleus is increased due to the recoil energy of the emitted alpha and beta particles. It again comes back to the ground state, and thus in a secondary phenomena it releases gamma radiation. So radioactivity is a phenomena where alpha particles are released, beta particles are released, positrons are released, neutrons are released, and in the same way, in the secondary phenomena, the gamma radiations are released. Now it is very clear to you all that what actually the radioactivity is and how it works.